Alright, so I have a pile of parts and I need to have an assembled chassis after this is done. So the robot I'm working on today is a Mantisweight that is going to be featured at the next RSL in May here. It's upcoming in about 2 weeks. I'm hosting the event, but I'm going to take the time to run this robot for a couple of matches as kind of a bit of a sideshow. We're hoping to get the Mantisweight class back in operational. So part of that is making sure that people are properly inspired to do so. So what you're looking at is a pile of parts, a lot of UHMW, carbon fiber, TPU parts, and when it's done, it should hopefully look like a small version of Whiplash. I had DJ Carpenter commission. I commissioned him to make this design, and then I put a little bit of my own special touches on it, cut out the parts in my own shop, and then we named it Piplash as a bit of an homage to Whiplash. And now I have to figure out how to actually get everything together and make it look proper. So I think I'm just gonna kind of start off with the outer rails, and we'll just kind of work from there. So there's a bit of a keen feature for the shafts. I don't have those quite yet, but we're just gonna get as far as we can with what I do have. Got my McMaster car order in earlier today. They have amazingly quick shipping times. I ordered my parts from them yesterday afternoon, and I went to check on the tracking ID, and basically they pulled a magic trick on me, and they said check your front yard, and they're already there, which was a nice thing to see. But we're just gonna kind of wing it for now and see what we come up with. See if I come run into any trouble or if it's all pretty obvious. I think I'm gonna start with the outer UHMW rails and kind of work my way in from there. First time using this screwdriver as well. This is one of the Amazon Basics. It was rated pretty highly on all the videos that I saw about it, and I haven't had a chance to use it yet. It's a little quick for my taste, but it seems to have a lot of power. It was more power than I was expecting from something this small. So in the back here, these are just number 6 plastite screws. These ones are 3/4 of an inch long. So plastite screws, if you're not familiar, are a lobed screw, and essentially they grip into plastic really well. Um, Not too worried about those ripping out at all. I think they're going to hold up really nicely. We've ran them in 1 pounders, 3 pounders, 12 pounders. Never had any real trouble with them. So there's a small pilot hole that's been drilled on the inside of these already. Hard to see because everything's black here, and it's kind of low light. But there's some 1/8 inch holes drilled for the number 6 screw to go into. Make sure I got that on the right way. So the rear wheels in this case have dead shafts. So it's utilizing 2 of the heavy duty beetle weight shafts from Repeat Robotics. So those are still on their way. I just ordered those yesterday. And then the motors are the Repeat Maxes, or no, Pros. I forget which are which. The naming convention's a little confusing to me. But so those are going to here, and those are plenty large to run a 6 pound robot with. It's not gonna have much struggle there. And then now I have 2 plates. If I recall correctly, yeah, this is the outside of the plates, but I got to put this central piece in before I do that. So I'm gonna set that to the side. So there's a central spreader. I printed this out of PLA just for a little bit of extra rigidity. Shouldn't be taking any hits where this piece is located. So this section allows the wires to route underneath the robot from side to side because we'll see once it gets going. The 2 sides are completely separate. So I think I need some 3/8 inch screws, 1/2 inch, and those are 3/8 number 2. I need 3/8 number 6. Number 6, 3/8. There we go. So 3 of those per side. I might want to bump these to the 1/2 inch. They look a little short. Yeah, those are too short. I'm gonna go for the 1/2 inch. So we'll get the center assembly done, and then I'm gonna go after placing it in with the back, and then we'll bolt it down to the other plate. Didn't hear any cracking from the PLA, so that's good. All right, so that's one side done. And I'm probably gonna have to pull things apart again to put in the rest of the components. I'm still missing quite a few parts. Everything's showing up in the mail soon, but we'll get as far as we can. Go. And I'm gonna try to do more of these build videos. I'm really not a fan of taking time to edit. I just don't have enough time to devote any mental thought process to editing videos. So I'm just not going to do that in this case. Instead, we're just going to do these as one big, long, continuous take. And if we screw up, we screw up. It's fine. You guys can berate me in the comments about that when I do. But this will get me to actually post up stuff more regularly. All right, so there's 2 of the back screws, 4 to go. All right, this little screwdriver is pretty handy. I like this guy. It's very fast. I think it might actually be faster than the like the M12 Milwaukee that I have that I use for the CNC service upstairs. That's the normal go-to for me. I've no doubt that Milwaukee has more torque, but I think it is slower. All right, so there's the base frame. I don't have the metal segments for the front yet. There's 2 aluminum pieces that go up here to mount the wedge on. Um, haven't bothered cutting those yet, just haven't had the time. But I'll get to that pretty soon here. And then, so here's the base panel. This base panel, I don't think has any directionality. I think whether it's flipped over or not, it should be fine, which is nice because if it gets a little bit damaged or scrubbed up, I can always flip it to get a clean side again. But this is 2 millimeter carbon fiber, and we'll drop this on there real quick and make sure everything lines up nicely. All the holes look like they line up pretty decently. I think it'll be good. So I'm gonna use the 3/8 inch number 6 screws down there again. Ooh, there we go. I don't like the position of this button. I think that's the only thing I have against it. So I'm not going to tighten them down all the way. I'm just going to get them started, just in case there's some like fine adjustment that needs to happen. Back those 2 off a little bit. So there's a reasonable amount of screws down in the bottom. Nothing crazy, but since the robot's serviced from the top and only one of these panels has to be removed to pull out the battery, I'm not too worried about serviceability. I'm not a huge fan of an over amount of screws, but this seems like the right amount. And then there's 2 additional holes on each side. So there's 2 holes here, 2 holes here, and then same on the other side. And those are for plates to mount the top panel to. There's no, with how the central arm support is, there's no way to mount those on there otherwise. So what DJ did in his design was he made these little combination of a motor guard as well as a standoff holder to be able to firmly support those in there. So we'll work on those next. But for now, 2 more screws to toss in here, or 3 more. And then I got to make sure all of them are tightened down. All right, I think that's it. So just give them a final tighten. You gotta be careful not to over tighten with plasticites. You can strip out the threads pretty easily. That's the one thing I don't, or one of the other things I don't much care for on this is that there's no um, torque limiter. Whereas that's one of the nice things about the Milwaukee M12 that I have is it has a torque limiter on it, so I can set it to whatever setting works well for the screws, and then just pull the trigger until they stop turning. All right, so we got the base on there now. It feels pretty rigid. It's yeah, it's not a lot of movement there, so that's good. So now we need to find the screws that go through these. Um, and then so there's little hexes cut through the printed section there, and then these standoffs just press into place, right? So they're in there pretty hard. Like removing that's going to be difficult. Um, but they probably won't need to be removed very often. So there's 8 of those that need to go in. So I'm gonna press all those in right now. Yeah, those are pretty stiff. See if we can do them 2 at a time here. Get them started, and then it's denting my table. It's a nice table I'm denting. Let's dent it over in the corner where I don't care about it as much. All right, so that's 2 down, 2 to go. So one of these is a motor guard for the lifter. 2 of them are motor guards for the drive motors up in the front. And then one of them, this last one, just houses a finger tech switch. So it's got a little spot here for the finger tech switch to go into. All right, so those are all done. Time to throw them into the robot. I got to find the right screws for them. Number 6, 32, 3/8 of an inch long. So these are the non-plastite ones. I think these are the screws for that. I looked in the CAD, bought every single screw that I needed in a very high abundant amount, and didn't really pay attention other than that. Yeah, that's right. So I need a different head for that. I guess I'm doing those manually. You know what? I only have metric down here. That's a close enough fit. We're gonna make that work. Actually, I might have this set right here. All right, looks like I do not, but we're gonna make it work. Because I'm not gonna go upstairs to take care of this. All right, so this one should be front right. Pretty good tight fit. This one is um the lifter arm, which is back left. This one is front left. And then this last little guy is back right with the fingertech switch. Now let's fit nicely. The screws lined up perfectly on the bottom. And then I'm just going to pull that till I can feel the whole standoff suck in so that it's nice and flush on the bottom. Oh, all right, so that's one. When I do final assembly for this, since it's aluminum with a steel screw, I'll put a little bit of Loctite in these just to make sure they don't back off. The plastite screws generally will not back off with vibration, but these guys could. So I don't want them coming out and hanging up the robot since they're on the bottom. So I'll put a little dab of Loctite on them when I do the final assembly. For now, I just have to make sure everything fits so that when I go to put in the rest of the parts, if I need more time, I need to be able to cut the stuff now. So I want to make sure everything fits beforehand. All right, so that's 3 of them in and 1 more to go. And then the CAD files for this one are up on the RSL website. If you search for Mantisweight or Piplash, I think, Piplash, they should pull up, and it'll require you to sign in to download them. So basically, check it out. It's like a normal item in the store, and I'll put a link down to it below. All right, so there's that. I got the arm sitting somewhere too. I'll go grab that shortly. And then we got the top covers. So the top cover has a slot for a switch, and then they're reversible, so they can go on either side. If we did this just a little bit differently, if we center up that finger tech switch, we can probably actually just use one single hole in the center, which would allow for, well, I guess if you flip it around, the holes don't line up. It might be worth putting an additional hole on both sides because it doesn't hurt anything for it being up in the front, but that would allow it to be flipped over if it took damage in a weird way, and we needed to like flip it to get that segment back to where it needed to be. So 2 of these per side are the number 6 button head cap screws. There's the regular screws, and then the rest of them, the other 4 screws are for the plastite screws that run into the UHMW. All right, let's get the other side on. Pretty satisfying build so far, though. This is going together really quickly, faster than I had imagined. Which is good because you want to be able to work on the components quickly while you're at an event. A lot of events only have 20 minutes between rounds, or as little as 20. Most times it's much longer, but you have to be prepared to fix a robot in about 20 minutes in most cases, which means you have to have multiple batteries. Because if you charge your batteries at a normal rate, that's not a lot of time. Most times batteries that are fully depleted will take roughly an hour to charge, unless you're charging them dangerously fast. It'd be nice if all of these were the same, since they're the same type of screw, if they had the same head on them. So I might order Torx versions of these other screws and see if I can't get them in the exact same head size, which is T15, it seems like. Because then I don't have to change tools to do it. But the advantage of doing it this way as well is since they are a different screw that thread into a different location, I don't want to take one of the plastics and accidentally drop it down into the standoff because that would be no bueno. But yeah, so that's the base chassis done, minus the front pieces. None of the armor sections are on yet. None of the motors or any of that are in here yet. And then I think in the next video, I'll cover assembling the arm. So that has a printed gear in the back. and a bunch of standoffs that go through that, as well as a big shoulder bolt that goes through here, some bushings that have to be pressed in, and then it has one of the repeat hub motors up in the front with a custom AR500 disc for it, and then just two big long forks that come through. So I'll work on that in the next video, and then after that, once I get electronics in, we'll toss those in, wire up the robot, and give it some test drive and see how everything goes. But that'll be it for now.